WarsawJS.
Welcome to the talk Anatomy of a Good Test. Let's get started. Let me first quickly introduce myself. I'm a senior software engineer here at Snowflake. I've accumulated about 20 years of full stack software development experience, almost always being close to the web. My view on testing is strongly influenced by the opportunity I had to work in test-driven development and pair programming practices. As for the technical aspect, I've been using Jest and vtest with React testing library and previously Enzyme to test React applications, Karma with Jasmine for Angular apps, and as for end-to-end tests, I did use a bit of Cypress, Selenium, and Playwright here at Snowflake. On the backend, where I've been mostly working on Java Virtual Machine, I've used JUnit, sometimes with Mockito. On this talk, I want to take you on a bit of a journey. At the start of this journey, we have this nightmarish piece of test. Along the way, I'll be applying 6 traits that I have found to be essential for a test to be good. At the end, we'll arrive with a test that is a pleasure to read and work with, as well as a toolbelt of practices to follow. Looking at this piece of code, it's hard to even grasp the intent of it, but don't worry, we'll be getting back to it iteratively, improving it along the way. For some visual context, this test is verifying whether the items in the menu on the bottom right corner are properly enabled and disabled. And what we see here is actual part of Snowflake's web interface called SnowSite. And here customers can inspect the history of their test runs. Getting back to the code, so I think the first thing this test needs is to be more focused. So what do I mean by that? Each test case should focus on a single precise desired behavior. I prefer to avoid generic names like renders or works as expected. Instead, I use detailed test names so that the test runner output can be precise. A detailed name can keep you, the author of the test, focused. A detailed name keeps me from wandering off and cramming too much logic in a single test, making it hard to reason about and maintain. Do one thing and do it well, kind of a singular responsibility principle, but for tests. The side effect of it is that the list of all the test cases of a component will constitute a complete living documentation of all the requirements of that component.
Me and you, the author of the test, focused on keeping it small and to the point, to do one thing and do it well, and not to wander off and cram a lot of logic into a single test. And having this list of detailed names for a test case, that gives the benefit that you have kind of a living documentation of all the behaviors that given component has. So going back to the starting code, first of all, the name is too generic. Interactions works expected. Second of all, we have, skimming through the code, I see 3 expect assertions. One is a kind of technical one. One is checking if one row has a disabled query profile option. The other one is enabled. So I would keep it more focused. First of all, change the name to say exactly what I'm doing. Should render disabled query profile option if query is not available. And then expect only that. And keep the other thing in a separate test. OK, that's a bit better, but still a long way to go. So now let me make it more structured. So there's this convention, the syntax called Gherkin, the given, when, then. And a question for the audience, and I have swag to give out. What's the relation between Gherkin and this pickle here? Do you know what might be the... Yep, that's a prize for you. So I think what I found is that the Cucumber JVM testing framework introduced the Gherkin syntax. And Gherkin is actually as well the kind of a cucumber you use for pickling. And it's also, in German, it's Gurke, is cucumber, so probably all of this. OK, never mind. So what the Cucumber framework calls Gherkin syntax is the given, when, then. And this is the gist of it is I'll have 3 separate sections in each of my tests, starting with initialization, the given, where I set up the environment, dependencies, and the requirements of a tested component. Then I go to execution, the when, where I perform actions to get the component into the desired state. And lastly, expectations, the then, where I put all the assertions on the expected outcome. And this forces me to make the test simple, not to cram a lot of logic to it, not to it become a script of intervening actions and assertions. So it makes just the test so much clearer. Oops. To apply it to our test, it's going to be actually quite easy, because it already follows this, this flow. First is the initialization of the data, then actions, and then the assertions. So what I would do, I like to place the comments and make it really clear in the code when each of the section starts. All right. So now what is left, I think, is there's too much of a technical detail in this code that clouds the intent of this test. So I would make it more high level. So the aim is not to mix high-level and low-level concepts in the code, because that makes it harder to comprehend, like switching from thinking about test runner details and then the business logic. So high-level concepts would be like actions like clicking or selecting the interface and things like buttons and icons. And low-level would be DOM nodes, event handlers, endpoints, or network calls. So finally, the test code should read like a manual scenario. So for example, if I would to read out loud the code on the right, it should be understandable to a tester that could click it through on the application. So when I read the code, like given the response to the API endpoint, when I render items and wait for it to load, when the user clicks on item 2, I should see details 2 to be on the screen. Like it feels natural and easy to comprehend. So here in the code, we have a few technicalities. And first of all, there's direct use of mocking. Then there's some setting up context providers for the React component that it's not really bringing much to this, test, but it's required. And some interactions of the rendered DOM nodes. So I would easily abstract this into a few methods. So first of all, the data preparation to a given task history method. Then hide the complexity of the context setup or anything that might be required to render in the render test component. And a few other verbosely named methods like wait for the table to be loaded, details button of a given task, or find menu option. Another option is to extend the testing framework, like here on the last line. To be ARIA enabled is an extension to the expect that hides the raw access to the HTML attribute. One thing to note here is also something I like to follow in the given task history method. So what I usually do in the data mocking methods is that they have defaults. Like every field is filled in, but I can overwrite any field that I want. So in this state, I'm only interested in the query ID being empty, because that's what I'm testing. And I also would supply the name, because that's what I'm referencing in the actions below. And all the other fields that a task might have, like created date, status, database, and schema, I'm not interested here. I rely on the defaults. So to have it as little information here as I need, but all the things that I need to be explicitly stated. And we'll get back to how this method might look like in the implementation. OK, this one is kind of close to my heart because of the test-driven development experience. Test on the API and not on the implementation. So what I do in a test is I interact with the component using its public API. So what's a public API component? It's its inputs and outputs, first of all. So what I'm passing via props in React, as well as the execution environment, like the browser with its networking, navigation, local and session storage, as well as the global state of the application that my component might assume that is available at runtime. So these I feel I can freely mock or construct, especially for the test, but I avoid like digging into the code and replacing modules, replacing some functions inside the implementation. And like, the general rule would be, don't mock your own application code. And why is it important? Because what I find is that the biggest benefits of having tests is the freedom and safety to refactor the code, to make the implementation better. And the more your test is tied to the implementation, the more any change you introduce is going to break the behavior, break the test, and not break the behavior. So I want to be able to extract components, introduce new abstraction, change the data fetching library, and run the test to be sure that I didn't break any behaviors, because that's not what I want to break. And if I have ties to the implementation, then they don't give, then will not tell me much. So in our test code, we've already extracted the given task history method, and it can be implemented in different ways. So, like starting with the initial implementation that used mocks, it might have been implemented like this. So where the top function is the first implementation, and it uses, it replaces the hook that the component is using to not do actual network fetching, but to return the data. And here I have the code that I mentioned before for having defaults, but allowing for allowing them to be overridden. Instead of this, I would use, for example, move the mocking a lot further on in the stack. So, for example, use a knock library that allows me to spin up a network, a local server that will respond with the data I want for the test being. And this gives the space between what is rendered and what is mocked, and the whole thing inside the implementation may be changed, and the test will still be green. And I want the freedom to be able to improve the code, extract components, and stuff like that. Okay. Number 5, collocated. So this one is more of an organizational one, but it has some desired consequences. So the gist of it is that I prefer to put the test code right beside the production code. So if I have a task list component in a task list file, I would have a test for it sitting in the same directory besides, called task list test component. And the first benefit of this is that it's easy to find the test, right? And the test is a documentation of all the behaviors component, great. But the second less obvious is that this practice steers you into having tests at the lowest possible level. But if you have a shared method extracted to a file, then it begs to have a corresponding test file that unit tests this method. And for every component that introduces some logic, there should be a separate test file right beside it to test exactly that logic that is introduced in this production code. So then your tests on the higher levels rely on the components you're using working properly because they have their tests beside them, and on every level, every piece of logic is tested right beside. And this leaves very little to be tested on the end-to-end level, and that's a good thing, because end-to-end tests are usually the most expensive, the least informative as to the reason of the failure, and kind of flaky because of all the moving parts that they have to interact with. And I really do prefer to keep my tests, E2E tests, as like a last resort smoke tests. So in our code, this could be a possible implementation of the component under test, the task history list. And the question is, what logic is introduced here so that there need to be tests of that logic on this level? So first of all, we have getting the data and displaying it by iterating over the tasks. So first test, it should show tasks from endpoint data. Second, the decision is made whether to show the spinner or the table. So second test, it should show spinner while loading. Then in the middle, there's a decision whether to enable or disable the item show query profile. It should render disabled query profile option when query is not available. And also on click, there's the calling to the navigation method. It should navigate to the task query history profile. Okay, the last one for this talk, is isolated. So imagine one of your tests is failing on CI. And what I usually do in that case is pick the test and run it locally, try to reproduce the problem, dig into it. And what I don't want is for the test to be green when run in isolation and failing when run of a suite. Because finding which pair of two tests only fails when run together is really tedious and kind of boring. So to avoid that, I never make my tests dependent on any other test, and try not to share any state between them. This means setting up the whole environment and any requirements from scratch or resetting it fully before every run of the test. And you want that because tests should come and go in your application. Like some of the features might no longer be desired. Their product changes their idea how the product to use, so you remove the components and test. You should be adding your tests when your product is evolving. And you don't want to you remove one test and the other one is breaking. So you want to do it freely. One way to have the dependency between tests is the temptation to have a continuation test like this, where the first one is testing something, and after that, the other one picks up right after the first one left. So this would work if you run them sequentially, but the second test will always fail when run in isolation. So I would really get that logic that we have already using high-level constructs and duplicate it in the test below so that it's fully independent and encapsulated. But there are also some more subtle ways to introduce, to break the isolation of the test. Like, let's go into the render test component method. So we move the context setup there. And there's another question for a price. Can you spot how the second test will run successfully when run on its own, but will fail if run together with the test that we've been working on? In the meantime, I'll be explaining the code as you see it. So in the render test component, we have our component, and then we set up telemetry. Telemetry meaning that's going to be gathering the interactions with the page to push it then to have the log of what the user is interacting with. And it's going to be placing it in the test telemetry object in the array. So the second test, it emits task action telemetry events, is rendering the component, clicking on the show query profile and checking if the registered events got this telemetry event. So can you guys think of how could this break when run together?
Depends on the state, right? In the first test, if we will set something there, then the array might be more than this one.
Yeah. Is this the same? Yeah. I have two prices. Sorry?
Can you repeat the question? Because
The question was how this second test can run successfully in isolation, but when run together with the first test, it will fail. And the answer was that we're checking for the exact array if it's one element, and the first test is going to pollute this telemetry events array because it's also clicking on the show query profile. So the solution to that is simple. Just reset the array on every render. Start with clean slate. Do not share anything between the tests. Keep in mind that the environment should be set up from 0. So these are the essential traits I find for tests to be good. And good meaning easy to read and maintain and giving valuable feedback. So focused, starting with a good name, structured for easy navigation inside, high level for the ease of reading it, and on the API to be resilient to any refactorings, collocated for convenient discovery and restrained scope, and isolated for easy debugging and maintenance. And if you're an engineer really into testing, we have a few open roles in Snowflake. One of them several of them is we're looking for SDETs, meaning software developer engineer in test. We're looking for engineers who might want to switch to focus more on testing, or the test engineers, and check out our other roles. And that concludes my talk in time.
Stay right there.
Yep.
Don't go anywhere. Stay right there and speak, please, into this microphone, okay? Closely. That was great, right? Everyone enjoy that presentation? I'm wondering about ourselves. Are we co-located? Are we isolated? What are we anyway? Does anyone have any questions for Krzysztof about this talk? Any question whatsoever? There are no dumb questions. Every question will be appreciated. Any questions whatsoever? Hold on 1 second. I'll be right with you, sir. Take this.
Thank you for presentation. I have one question. How often you run your tests on CI, on each commit, each pull request, before releases?
We run them on every pull request. Before the pull request can be merged, all the tests should pass. Yeah, so we run them often. Like, we have a lot of tests for Snowsite in tens of thousands. So I often don't run them locally, the full suite, only the tests that are close by code that I'm changing, but the full suite is run on every pull request.
Was that a good answer for your question, sir? Next question? Oh, okay.
All right, you have said that you want your tests to be isolated. Do you verify it in any way?
Actually, we could do it. We don't do it, I think. We could like randomize. There are tools for that you can run the suits like on the site with the flags to run them in different order, so that could pick up those lack of isolation. But actually, we don't have that much of a problem with that. It happens rarely, and keeping your discipline like saves you from having that problem at all.
All right, thank you.
Thanks.
So you talked about unit testing and also a little bit about end-to-end testing. Like, it's good to have some end-to-end tests, but not too much. And I respect that. I don't like end-to-end tests at all. I think they are clunky and often too complicated. However, I was about to ask you, what do you think about integration testing? How does it fit into the picture?
So I guess we had this kind of big discussion between whether what I was describing is still a unit test or is an integration test. Because there's no shallow rendering, like it does render the whole stack. I'm okay with the assertions to pick up the DOM elements, not only on this level, but on another level. So I kind of feel these are the integration tests because they do a full sub-render of the tree. And if we have tests on really the whole page, like the page that I showed, we have tests on that level. So they render a whole tree with the mockout source of data. So I feel these are the kind of integration states we have. And after that, we have tests running with the actual build application with the actual backend.
Good answer? Okay. Any other questions for Krzysztof? Oh, you got the mic. Go ahead.
Hi, Krzysztof. Thank you for your presentation. It was great. I just wanted to add, and also I'm really happy that we follow those rules in my project, so good to know that. I just wanted to add as a tip for you guys that they find queries. If they do not find anything, they throw an error, so you actually do not have to then check whether calling the to be in the document method, and also you do not have to check for the to have attribute methods because the find queries support the configuration object where you can pass the variables as disabled false or disabled true, check true, and check false. Just to add to your presentation on the top. Thank you.
Do you have a question?
No,
no, I'm sorry.
I can still relate. I thank you. Yeah, you're right. Though sometimes I still feel a need to have the expectations statement, the then. What do I put in then if my finds before that will throw? Okay, but I want to show the reader of the code that I want this to be visible. So I'll even put an explicit expect find to be in the document, even if I know it's going to not fail before, but I want to explicitly state what I'm expecting here to happen.
Yeah, sure.
Thank you very much. Yes, more time for discussion later. This is a great opportunity for me to remind everyone to please have a question. Sometimes it happens that you make a short statement before your question. However, we really, really encourage you to ask questions so that you can get some good answers from this man.
Thank you for the talk. I wonder about your TDD workflow within your company. Are you doing that? And how you do that? Is every engineer also responsible for writing their own test, or is it only done by you QA guys? Okay, there are a few questions there. So starting from the last one, yes, every engineer is expected to write the test for their own code. And beside that, we have some software engineers in test that kind of work more on the end-to-end tests. And as for TDD, that's, I think, is a topic for a whole new talk. It can be done on the front end as well. I don't do it all the time, but when I have the well-defined requirements, well-defined what I need to do, then I start with writing out the behaviors in the test using the roles or test locators. You can write up what is expected. When I click this should pop up. When I click this should close. You can write it even before you have the implementation. So when I can, I do it. It's not always you're extending some component and fighting with the browser. Like it's going to be harder, but and it's also, I said, it's not a company policy. Like the teams can do it if they want to.
Let's thank Krzysztof again for his fantastic presentation.